In this video, I will give a basic introduction to trees. Before we go into deeper detail, let's get familiar with some of the terms we use when we work with trees. So basically, trees are a set of nodes that have a parent-child relationship. Now, in order to understand the parent-child relationship, we should first understand what a parent is and what a child is. So basically, a parent node is any node through which you can go to other nodes. So for those other nodes, the previous node would be a parent. So for this example, 3 would be a parent node to 6, 7, 8, because from 3 you can get to 6, 7, and 8. So 3 is the parent of 6, 7, 8, whereas 6, 7, 8 are children of 3. So in this case, this would be the parent, and these would be the children. Now, every tree has a root node, and a root node is basically a node that has no parents. So in this case, 0 is the root node, and basically this is where your tree starts. So this is called the root node. Now you also have things called leaf nodes. So leaf nodes are basically nodes that have no children. So in this example, 4, 5, 6, 7, 8, these are all leaf nodes. Also, 1 is a leaf node. So a node is a leaf node because it doesn't have any children. It doesn't matter where in the tree that node is. So that node can be at the top of the tree or the bottom of the tree. It doesn't matter. Now, we have something called ancestor. So for any node, everything, so each of its ancestors is basically its parent and its parent's parent and so on. So for the node 4, its ancestor is 2 and also node 0. Same for 5, its ancestor is 2 and node 0. Now the descendant node is the opposite of that. So for node 0, this whole tree is its descendant because it is the root. And it makes sense, right? Because root is the starting point of a tree. So everything below everything that you can get to through the root has to be its descendant. So what are 2's descendants? Well, 4 and 5 are 2's descendants. Now you may have noticed that 4 and 5 are also 2's children. So basically, descendants can also be children. And same goes for ancestors. So parents can also be ancestors. So 5's parent, 2, is also 5's ancestor. So let's talk about concepts of depth and height. So what do I mean by a depth of a node? Well, basically depth is defined as, for any node, say V, depth is 0 if V is root, and if V is not root, then the depth of V is the depth of its parent plus 1. So depth of parent plus 1. So let's see if we can figure out what the depth of these nodes are in the tree. So depth of 0. Well, is 0 a root? Yes, it is. So therefore, depth of 0, so let's just, depth of 0 is 0. Now what is depth of 1? Well, since 1 is not the root node, we have to go through here, which says that it's the depth of its parent plus 1. So what is the depth of its parent? Well, the node 0 is its parent, so depth of parent is 0, therefore depth of 1 is depth of parent plus 1, which makes its depth 1. So similarly, let's do depth of 4 and depth of 7. So in order to know for the depth of 4, we need to know the depth of its parent. And in order to know the depth of 2, which is 4's parent, we need to know depth of 0, which we know. So depth of 2 is depth of 0 plus 1, so depth of 2 is 1. And then depth of 4 is depth of 2 plus 1, which makes depth of 4 2. Similarly, depth of 7 is depth of 3 plus 1, and depth of 3 is depth of 0 plus 1. So depth of 0 is 0, so depth of 3 is 1, and depth of 7 is 2. So as you can see, this is basically a recursive relationship. If you want to know the depth of any node, just find the depth of its parent and add 1. And if the depth of its parent is not found, then you can get the depth of its parent all the way until you reach the root. Now let's talk about the height of a node. Basically, height is the exact opposite of depth. Height is defined by this. If a node V is leaf, its height is 0, else the height of V is height of maximum of its children plus 1. So what do I mean by this? So basically, for any node, if it has more than one child, then you find the maximum height of the child and then add 1 to it. Okay? So let's just change this tree a little bit so I can show you what I mean. So let's say we add 10, or say 9 to this. Now 5's child is 9. So let's say we want to find the height of every single node in this tree. So we basically, let's start with the bottom, okay? So the height of 1, since it's a leaf node, is 0. Height of 4 is also 0. Height of 9 is 0. Height of 6, 7, 8, they're all zeros because they're all leaf node. Now we go on the second level. So we have 5. What is the height of 5? Well, height of 5 is the height of its maximum child plus 1. Since it only has one child and that child's height is 0, height of 5 is 1. Now let's look at 2 and 3. So what is height of 3? Well, as we said before, height of 6, 7, 8, since they're leaf nodes, their height is all 0. Therefore, height of 3 is 1. Now height of 2. Well, 2 has children of different height. It has 4, whose height is 0, and it has 5, whose height is 1. So we take the max of this, which is 1, therefore 2's height becomes 2. And same goes for this. So now 0, the node 0, has 3 children, whose heights are 0, 1, and 2. So again, we take the maximum of these and add 1 to it. So height of the node 0 is 3. And that's how we figure out the height and depth of nodes in the tree. In the next video, we're going to talk about trees in a little bit more detail. Thank you for watching, and I hope to see you there.